All right, let's dive into a brand new strategy for AI. This one could solve one of the most frustrating problems we've all faced, and maybe, just maybe, unlock the power to reason over a practically infinite amount of information.
You've been there, right? I mean, we've all been there. You're deep in a chat with an AI, you're building on the last 5 things you talked about, and then, poof, it completely forgets what you were talking about. This quote just nails that feeling, when the AI's memory just seems to go bad.
So there's actually a name for this phenomenon. It's called context rot. It's this bizarre failure mode where the more you tell an AI, the worse it gets. It's almost like its brain gets totally clogged up. And yeah, as the slide says, it just gets dumber.
And that really gets to the heart of the problem, doesn't it? How do you actually break past this limit? Is it even possible to build an AI that has a memory that isn't just long, but is practically infinite, one that never, ever degrades?
Well, here's the breakthrough idea. What if we've been thinking about this all wrong? What if, instead of trying to force one giant AI model to read an entire library's worth of text all at once, you could give it the ability to call up smaller, more focused versions of itself to chip away at the problem? Okay, so check this out, because this slide really shows the huge shift in thinking. On the left, you've got the old way. You just dump everything, the question and all the context, into the AI in one go. And that's exactly what causes context rot. But on the right, this new recursive method is so much smarter. The main AI only gets your question. All that massive context, it's sitting over here in a separate space, and the AI itself gets to decide how to explore it by launching these little targeted mini-calls.
And this whole strategy has a name, a Recursive Language Model, or RLM. Now, the most important thing to get here is that this is not a new model you have to train from scratch. No. It's a really clever strategy for using the models we already have, and it lets them break down and interact with a context of basically any size you can imagine.
So how does this all work in practice? Let's get into the mechanics. And the best way to think about it is with this analogy of an AI working inside a programmer's personal sandbox. Here's how the process unfolds. First, the main root AI gets only your question. That massive context file, it gets loaded into a secure coding environment, almost like a variable in a program. Then, and this is the cool part, instead of just trying to read the whole thing, the AI starts writing its own code to explore that context, launching smaller, recursive AI calls to investigate specific pieces. Finally, it gathers up all the little answers from its subqueries and puts them all together for the final response. It's like a lead researcher delegating very specific tasks to a huge team of assistants. And what's so fascinating is that once you give an AI these tools, it starts to act just like a human programmer. The very first thing it often does is what's called peeking. It'll write a tiny piece of code just to look at the first few lines of the data, to get a feel for the structure and the format. Okay, so once it has the lay of the land, it pulls out another classic programmer move, grepping. This is basically just a super-powered keyword search. The AI writes a simple command to find every single line that has words that are relevant to your query. And with that one move, it can slash a gigantic 1,000-page document down to just a handful of really useful sentences.
But what if a keyword search just isn't going to cut it, for those more complex, nuanced questions? Well, then the AI uses a partition and map strategy. It literally breaks the context down into smaller chunks and then sends a recursive query to each one in parallel, basically asking, hey, is the answer to my question somewhere in your little piece of the text? It's a classic divide and conquer approach, and the AI orchestrates the whole thing by itself.
Okay, the theory is brilliant. It sounds great on paper, but does it actually work? Let's take a look at the results, because this is where we really see how a smaller, smarter model can absolutely dominate a giant. So the researchers put this to the test on something called the OOLONG benchmark. And look, this is not some simple find the needle in a haystack test. This thing is designed to be absolutely brutal. It forces the AI to do really complex reasoning over thousands and thousands of entries. It's a task specifically designed to trigger context rot in normal models and make them fail.
And the results are? Well, they're pretty shocking. As you can see right here, the massive GPT-5 model, when you just give it all the context at once, it scores around a 30. But a much, much smaller model, GPT-5 Mini, using this new RLM strategy, is scored a 64. That's more than double the performance. And get this, not only was it smarter, it was actually cheaper, on average, for each query. So clearly, this RLM thing beats context rot. That's a check. But how far can we push this? What happens when you scale up from just one long document to something ridiculously large? Something the size of an entire library.
Let's start with the baseline. If you face a powerful model like GPT-5 with a task where it has to find information from a pool of 1,000 different documents, it just fails completely. Its context window isn't even close to being big enough. Even if it tries to shorten everything, its accuracy is a flat 0. It literally cannot handle this scale.
Okay, so what about a fancier setup? An AI agent, which is a model that can use tools like a search engine, it does a lot better. It manages to find some relevant documents and gets about 70% accuracy, which is good. But it's not perfect. It still really struggles when it has to piece together little bits of information scattered across a whole bunch of different sources.
And then, you have the recursive language model. Using its divide and conquer strategy, it achieves a perfect 100% score. And it maintains that perfect score even as the context scales up to 1,000 documents. We're talking over 10 million tokens of information. It is the only method that can perfectly navigate this enormous information space.
These results, they're not just a small improvement. They're suggesting a fundamentally new way for us to think about AI capabilities. This is really about the future of inference itself.
So why is this such a game changer? Well, first off, it gives us a path to infinite context without having to train bigger and bigger models. Second, the AI itself, not some human programmer, gets to decide the smartest way to break down the problem. This means you're scaling intelligence at inference time, at the exact moment you ask the question. And finally, and this is huge, as the base AI models get smarter, this RLM strategy will just automatically get more and more powerful right along with them.
And that just leaves us with this one staggering final thought. Forget analyzing a single document. What becomes possible when an AI can read an entire company's internal knowledge base, or every scientific paper ever published on a topic, or the complete legal code of a country, and reason over all of it in a single question? The potential for new discoveries is just immense. The only question is, what problems are we going to solve first?